All right, welcome back. 1MO3, structure property relationship of materials. And in this video, I will talk a little bit about the class of material. So hopefully you have already learned about the material type of game and you have chosen the right materials. And you have learned a little bit of what is material property. So with that, we can translate and talk about different type of materials. And since this is still an introduction, into the topic. We won't go too much in depth about it in this video, but just to introduce you to the concept. So in total, we actually have 160,000 known material currently to humankind. And so this is a mess. There is, I talk about stainless steel, I talk about steel, but steel actually have many types. So within that group, there's actually already hundreds of variants. So engineers use the terms class of material to basically sort them out into group, and it helps us to visualize and kind of get a sense of what that group of material is. So in general, what we do is we group material property to be similar, material that have similar material property together, and we'll find coincidentally, or not necessarily coincidentally, it actually has a reason. Scientifically, the chemistry of those materials tend to be very similar. And the reason is there's the atomic physics behind it. And we'll talk about it in this course. So in general, we have a filming class of materials. We have metal, we have ceramics, we have glass, we have polymer, we have elastomer. So elastomer is a specific type of polymer where it has an elastic property. And so, for example, rubber, silicone is very highly stretched, and when you let it go, it bounces back. That's elastomer. And then we also have finally another group. So we have 5 plus 1. The sixth material class is hybrid, composite. So let's have a look at this graph on the right-hand side. So here we have strength versus density. And in the Granta EduPack, you can actually plot out each of this material bubble. So the ANSYS Granta EduPack, you can plot out this, and you can see we have different type of material class. In Granta EduPack, they even subdivided ceramics and technical ceramics to be non-technical ceramics to be 2 class, and natural material and hybrid to be another 2 class. But in general, that's basically what we have. Metal are usually material that are in a transitional metal in the periodic table. We have aluminum, copper, zinc, titanium, and steel. They're usually electrical conductor. So why they are electrical conductive? We will talk about that in our electrical property lecture. Polymer are usually organic matters made out of monomer polymerized into a network. So these are called polymers. They have relatively low melting point. They are not as strong as metal, but they're lightweight. So they're in this mediocre regime or middle regime. But they are relatively cheap, and they can be molded into various forms at very low temperature. So they have their application. We have elastomer, which is a specific type of polymer that do not melt, but instead, when you pull it, it doesn't actually have any kind of dink or plastic deformation. Instead, it's always elastic until it snaps. So you can use it to create stretchy materials. We have glass, which transparent, and then we also have ceramics. Ceramics are useful for they usually have high melting point, and they are used in for furnace application, high temperature application. They also have lower thermal conductivity than other materials, and so they could be used at high temperature insulating application. So for example, if you look at NASA, the spaceship outside, they would pad it with layer of ceramics that can help insulating the spaceship when it go back, relaunching back to the Earth. And on the outside of the spaceship, it generates a lot of heat, and so you need thermal insulator at that high temperature that does not melt, and so they use ceramics for that. And then finally, we have hybrid material. Basically, hybrid is a class of material that basically mix with any of the two or above materials. And so one common material that you may see is fiber composite, and it's used in gloves, sport equipment, as well as bullet vests. So one common material that is being used is carbon fiber reinforced plastic. It's made of carbon fiber, which is ceramics, and reinforced with epoxy, which is polymer. Put together, you have really high strength, lightweight materials. Not very recyclable, but it's very good for performance. So this hopefully give you a class of the 1, 2, 3, 4, 5, 6 different class of materials. And engineer often group different materials based on the similarity of material property in this material property chart. Okay. So we talk about that. So in the sense, what you want to learn from material science is you need to understand the structural property relationship. You need to understand how different material will have similar group of a material property combination. And the reason behind it is related to the atomic arrangement, microstructure. And so we will go in depth about that in this course. And then at the same time, if we can manipulate the structure, we can then change the property and expand this material property space. By doing so, we're doing good to other designers so that they can select the right material property for their application. So here is a summary of what is material property relationship. If you look at that, we have microstructure, we have atomic arrangement, we have crystal size, we have cracks, we have surface roughness, we have larger cracks, and all these can make a difference to the performance and therefore the material property of the specific materials. So in other words, you might think about that, maybe metal, ceramics, polymer, they have different type of bonds, they have different type of atomic arrangement that lead to the different property. Okay, so thank you very much for this video. In the next video, I will show you some practice questions on this particular topic.